Okay, Trip, I think it's a few minutes after, so I think we'll go ahead and get started. First off, hello, good afternoon. My name is John Dodds, and I'm the President and Chief Operating Officer of Kencor, which is an American Elevator Group company. I'm also the chair of the NAEC Member Services Committee, and I want to welcome everyone to this final Town Hall discussion of 2021. As you may know, the Town Hall series has become a series of dialogues with various leaders within the vertical transportation industry. These conversations over this past year have focused on topics that have been identified by NAEC members as important and significant ones for their business. The topics for the Town Hall sessions have been assembled from an all-member survey into topic clusters that range from immediate needs that you face daily to the longer-term objectives relating to successfully sustaining your businesses. As we move into next year, the Member Services Committee will need your guidance and input as we start to assemble our Town Hall events for 2022. We're going to try something a little new today. Hope this goes well. We're going to attempt to do a live poll, taking the next minute or so to put up a single poll question for you to answer. We're asking you to pick no more than 4 of the topics listed that may be of interest to you that we could cover in 2022. We have limited space, so we can't possibly cover all the topics that you may want to cover. So if you if you have an idea for a future topic that isn't listed, just put it in the chat box at any time during this event. We'll give everyone a chance to review and answer for a short pause. As everyone's going through and taking a look at those, just want to apologize in advance. I appreciate you all being patient. I've been a little under the weather for the last couple of days, so my apologies in advance if I have to go on mute once or twice during this. So as always, if you have any feedback in general, or if you have any ideas about future topics for future Town Hall events, please reach out to trip@naec.org. Today's topic is about technology, IoT, otherwise known as Internet of Things, and alternative testing. And this event will last for an hour and a half, ending no later than 3:30 Eastern Standard Time. Today's panelists will discuss tech solutions that they have utilized to increase efficiency and profitability within their respective roles within the industry. Tapping into IoT innovations with sensor technology can reduce expenses, increase safety, provide for learning opportunities, and provide data to better forecast maintenance programs. Today's session will also cover how elevator contractors can utilize alternative testing to increase safety, reduce wear and tear on equipment, and better prepare clients for future alterations. And finally, we will get a contractor's perspective on how technology and IoT can benefit contractors and their businesses. Before I introduce the panelists, I want to go over a couple of upcoming NAEC activities that you all want to be a part of. NAEC is holding a November membership drive. All new members who join in the month of November will get the 6-month pricing that is normally applied in January, including 2 free months of November and December. The target for new member growth during this drive is 40 new members. And if we achieve this objective, Matt Yellen from Peely has graciously put his beard on the line, and he will shave his beard at the end of the month for all of us to see. So help support NAEC's campaign, and let's see Matt shave to celebrate. If you're a current member and have not renewed your membership, the final day to renew is November 15th. All members who have not renewed by that date will be discharged, and all member benefits will only be accessible by membership renewal. Please see the email sent to the master account holder for your unique link to renew, or contact the NAEC office. We will be holding our upcoming 2022 Spring Educational Conference in Sarasota, Florida. It will be held March 20th through 23rd at the Hyatt Regency Sarasota. And in addition to the hours of great educational content that is on the schedule, we'll have the usual great social events and optional activities available. There will also be local tours and golf throughout the beautiful landscape of the region. Registration for the Spring Educational Conference will open next month, so look for those announcements. Speaking of the Spring Conference, NAEC is looking for programming ideas for 2022. Programming at all NAEC educational events is based on a regular call for speakers, as the association brings practical and relevant information to industry professionals. By featuring NAEC members as presenters, event sessions provide event attendees with the strongest forum for information exchange, problem solving, and networking. For the Spring Conference, the association is looking for general interest business topics, as well as elevator industry topics with an emphasis on code, safety, and emerging trends. To submit your idea for a presentation, visit naec.org or contact Laura in the NAEC office. Lastly, Space Draw for the 2022 NAEC Convention and Exposition in Louisville, Kentucky will open in January. This year's event will be held September 18th through 21st. All past exhibitors and supplier members will be contacted soon about the process and securing your place at North America's largest vertical transportation expo. With those organizational items out of the way, let's move forward with our town hall event. We will be going through our panel individually in roughly 15 to 20-minute segments. And when all of the panelists have had a chance to speak, we will ask some of the questions from the audience attendees. As you have questions, write them in the Q&A window, and we will circle back to as many of them as time allows at the end. Please note with your questions, if it is a question that is specific for one panelist, or if it's a general question for the entire panel. As always, we'll try to be mindful of everyone's time today, and we'll wrap up no later than 3:30. I'd like to start by introducing the first member of our panel, Guneet Bedi. Guneet has spent the last 2 decades transforming traditional businesses, employing traditional business models, to businesses employing as a service or reoccurring revenue business models. He started his career at Oracle, the database technology company in California, worked with Cisco, the networking company. In the last 6 years, he's been with relayr in the industrial maintenance and repair world. relayr is currently a fully owned subsidiary of one of the largest insurance companies and recently launched an elevator remote monitoring solution for independents. relayr believes that alternative remote maintenance and testing can lead to lower risk and better insurance. He lives in Austin, Texas, and has also lived in India, Germany, Sweden, Chicago, and the Bay Area. Guneet, welcome. Thanks for joining us, and I'm going to turn it over to you.
Absolutely, John. Thank you. It's a pleasure to be here. Thank you for the details and the reminder on the NAEC membership. We're probably one of the newest members, so we look forward to renew and we look forward to be there. And I've been always impressed by the locations that you all pick. It's good. New Orleans, Sarasota, go to Louisville. Sean, don't let us down. I've heard good things about Louisville, but yeah, no, it's really good to be a part of this community. And I'll introduce myself in a minute a little bit more, but we're outsiders. So, I'm an outsider coming in from the non-elevator world, and the really warm reception we've gotten from NAEC and all the members has been very heartwarming. It's been very, very good to kind of come in and talk about new ways of doing things, new technologies which the other industries have used, and how can we get your guidance and support to implement and use that in the elevator world. So like you said, John, I think I don't have slides. I just wanted to do a talk track today. From our perspective, when we started this journey, or I started this journey, I think a lot of you remember, software was not sold as a subscription and was sold as a one-off license. And today, I think a lot of you who spend money on software will see that you spend it monthly or annually. I'm sure some of you hate it, but it just keeps coming, right? It doesn't go. And the software companies in the Bay Area are getting very rich because, once they kind of come in, it's really hard to replace, and you kind of have that recurring small fee that keeps going. And then, the databases and the networking and data center world rose up and said, hey, why are we selling hardware? Why can't we create using technology and, data and artificial intelligence and all that good stuff? Why can't we create revenue models which are more sticky and more ongoing? And, COVID as the whole pandemic has taught us a good lesson that a lot of the sustainable companies which have stayed have had these recurring revenues versus the one-off revenues which you can push out. I'm sure the contractors here, the consultants, everybody feels about the pain when somebody says, hey, I'm pushing the budget out next year and come back to me next month and I'll talk about it. And I know I'm talking business, but I'll link it back to IoT and technology in a minute. So, we 6 years ago set out with this mission, which we've done, I think, reasonably well, on how do we have the industrial world have the same participation in this subscription economy. And how do we do this both for equipment makers, which we don't do in elevators, but in other areas like laser cutting and CNC machines, as well as motor and pumps. But more importantly, how can we create high value service stickiness and maintenance and repair stickiness for the industrial equipment? And can we create this into a recurring revenue model, right? Versus a model where every time you have to fight for a time and materials call. And what we do is we link the IoT sensor technology to an outcome. And secondly, link that outcome very closely to insurance. So is there a possibility for either, you're getting less or better insurance terms? Remember the progressive car dongle model where you put that thing up and, you can get a better insurance policy because you show you're a good driver. I would suck at that. I'm a bad driver. I'm a fast driver. But anyway, so for people who are good drivers, that works. And, also it would work. So, one is the angle of linking IoT technology sensors to reduction of insurance, but also more importantly, better servicing of the assets as of the cars specifically where we focused on, as well as increasing the amount of revenue you make and sticky revenue. And, it's funny, we do this in 5 or 6 markets. Motors, we do it in motors and pumps. We do a lot of it in boilers and, HVAC. We do it in, like I said, machine floors and CNC machines. It's very similar, right? The contracts today are getting eaten up, and specifically in the elevator world, I learned a lot in New Orleans in the full comprehensive contracts. A lot of it has been eaten up by unexpected breakdowns, of course, unnecessary callbacks, and just amount of time spent troubleshooting, right? And from our perspective, IoT is not just about connecting sensors and getting data. I mean, that's easy. That's the whole remote monitoring world exists. But how, more importantly, do you get the all of this unexpected waste of time and unexpected callbacks to reduce, so the staff and the technicians are a lot more effective? And a lot of people talk about IoT as, hey, this will take staff away, but we don't think so. We think this will actually create more revenues and more sticky revenues with existing staff, right? With the existing technicians, at least the way we think of it. So reducing the troubleshooting time, number one. Reducing the amount of callbacks per breakdown, because you want a less number of callbacks per breakdown. Of course, you can have as many planned visits. The more planned visits are better. And then react to wear and tear as it fits your schedule versus as an emergency wear and tear visit. And I think what we think is this really increases your customer loyalty, right? Because you're actually, the worst part to go and do a service call is when somebody's upset and the shit is not working, for lack of a better word. Whereas, when you go and service something and when, you're going to go help someone improve the life cycle of their asset or the lifetime of their asset, when stuff is working, you kind of build that loyalty, with the customer. So what we did is we spent a year and a half creating a hardware product, which sits on the car. It's agnostic of any car or any brand, I should say, right? Any of the big fours or others. It gets data outside of the controller, and it kind of gives you insights on, the vibration, the acoustics, the temperature, and various things that come in. But more importantly, how do you create some artificial intelligence and algorithms around it so you can actually, everything I said, can you reduce callbacks? Can you give more insights into the troubleshooting time? And that's how we think IoT is helpful today in this world. And so many industries have done this. Why not do this in such a fascinating industry with the elevator world? Specifically to kind of reduce that wasted time and activities which are mundane, if you may. So I think that's what we've been focused on, John, for a very long time. And now we've started to have some install base where we can do that. But where it gets really interesting is now, if IoT and data can give you that information, can you start putting stuff like uptime guarantees? Can you actually say, hey, I will make sure your car is up X number of times in a year, and I'll put my money where my mouth is and give an insurance. Of course, our parent company will back an independent or a contractor with the reinsurance, as we call it, in today's world. And by the way, can my liability and general liability go down now because I actually have a lot of intelligence on my install base? I actually know how my cars are doing. I know how my service technicians are doing. That's where it gets interesting, all the way to in Germany, not in the US yet, but we love to brainstorm. In Germany, we're getting to a model of penny per ride. Can we go to a model where the elevators are not sold as equipment or not serviced, more importantly, on a one-off basis, but you basically charge them on the number of rides or how the usage of the equipment is, kind of align with your customers' revenue. So, when I came in this industry, in the tech industry, I was, fascinated by how we can do that in the database world and switching and routing networking world. And we've now successfully done it in a lot of the, industrial world. And it really happens because you create this technology at the first level, which gets data, makes your asset predictable, and creates very dependable logic and business logic without dependency of any of the OEMs. And I think a lot of questions I'm sure people have is, we've tried this before, and yes, we have, but it has been very dependent on an Otis or a Thyssen. But why can this not be independent of the OEM, right? Why can this not be independent of the generation of the asset or the car or the controller? So I think that's where we are, and that's what we're enabling. And I think both the concept of IoT, of course, various technologies in here to operate, to better field service the assets. And then this allows for alternative testing and alternative business models like, insurance and, penny per ride kind of as a service models. In the testing space, it's interesting. We're also seeing how testing can lead to automated compliance, again, which is very interesting. It started in Europe, where instead of the checklist that an inspector has to do from a compliance perspective, can we automate all of this? Because we have the similar sensing points, we have similar sense of how far is the car from the floor from a compliance perspective. So we can automate all of that, which actually is prone less to human errors, and it's cheaper and it's more automated, and it's eliminates the mundane tasks for technicians, so technicians can focus on the high value tasks. So I think that's the kind of disruption, I think is the right word I'll use, disruption that we think IoT and technology and alternative testing can bring to the elevator world. And we're very excited that we have a first 7 or 8 partners trialing and testing our technology, one consultant and the rest independents and contractors. And just to kind of see how we can drive data and insights and maybe unique insurance models and save a lot of insurance, which we can spend in Louisville, Kentucky when we're there. So so that's the hope. And John, I'll turn it back to you. I don't know if you have any questions for me before I end, or if you want to wait for questions till the end of the session.
Yeah, so I do have a question or possibly two to follow up with you on. I'll try to save the questions from the audience till the end. You touched on something that I don't know hit home for me a little bit. I think I can kind of relate to your comment about, or maybe I'll just say, maybe in my opinion, I would agree that we've tried remote monitoring in the industry many times. Arguably, with limited success or some potential negative connotation towards the whole word, right? So why do you feel like this is going to be different, or what do you think about this
That's a really good
offering
question.
might make it work?
That's a really good question, John. And I think you're spot on. When you do monitoring for the sake of monitoring, or you do pilots for the sake of pilots, we call it pilot purgatory in our language. It's a different mindset altogether, because all you're trying to do is say that, does the technology work? And it's very easy for anybody to turn off the technology or remote monitoring, because it's something which was a check in the box. We think there was check in the box in our opinion, versus really leading to a business outcome or leading to making a technician's life easier. We think if IoT and technology is used starting with the outcome first. So we think we started with the right outcome, but we started with an outcome, right or wrong, saying we will reduce general liability and insurance, and we will reduce service callbacks and make them efficient. Now, we could do that with monitoring. We could do that with IoT. We could also do that with more intelligence from the field. So, in our solution, we don't just depend on sensors. We actually even depend on human intelligence, where, dispatchers and technicians can actually talk about an asset and say, hey, this is what I did, which is good and bad. So we feel if you start with just the remote monitoring world, which is one part of the problem, you're not solving a business problem. You're solving a technical problem. Whereas if you solve the business problem, you can solve it with remote monitoring or others. So in our humble opinion, that's why this will work, because we'll either reduce callbacks, increase our service margins, or get you better insurance. And whether we do that IoT or other technologies doesn't freaking matter to us, right? So I think that's why we think this is a better approach. Right or wrong, we'll see, but that's why we think it's the better approach.
And maybe just to ask you a follow-up to your answer there, I think the other possible negative kind of connotation sometimes that goes along with this is the goal strictly to reduce cost, or can we also impact our business, in other ways, such as being smarter or increasing revenue, as you mentioned? What are your thoughts on that?
Yeah, that's a good question. So I'll give you a correlation into the some other world of different assets. But today, in a lot of industries, specifically, let's say pulp and paper, the motor and pump world, more than 80% of the services that happen in certain area and certain segments is new revenues and service led, and it's special packages that people are selling because of IoT, which gives a higher life cycle of the asset, gives better availability and uptime of the asset, and it basically aligns with revenue. And in fact, we've also enabled something called a business interruption policy, which says if your pulp and paper plant goes down, I'll pay you loss of revenue. I'm so confident I'm serving the asset. So I think it's not just about the cost savings. I think it is really, unlocking what we call value pools, new value pools. And I think one of the biggest value pools in the elevator world we think we can unlock is availability and uptime of the asset, which will lead to new revenues. And of course, the biggest benefit in the back end, I think side benefit of that is lowest churn rate. We've hired a few people from TKE, and we know that churn of customers is so important in this industry. So if we can make the customers happy, then you all will have less churn. So I think it's definitely more than savings. And I think it's also more than just eliminating people and jobs. That's not the case at all, right? We want to basically make the current people more effective and efficient and get more revenue, is at least the way we think of it. So I don't know if that helps, Tom, but that's how I'll answer that.
No, that's perfect. Thank you. And quite frankly, very candid answer. So I appreciate that. With that, thank you and appreciate your time. Thanks for sharing your information. I'm going to move on to the introduction of the next panelist. Next member of our panel, Chris Dodds. Chris Dodds is the president of Liberty Elevator Experts, a company that provides both elevator design and elevator inspection services. Chris started working in the industry as an apprentice in 2002 with Kencor Elevator, located in the greater Philadelphia area. He's held various positions while working in the field by installing, modernizing, and maintaining vertical transportation equipment. In 2014, Chris founded Liberty Elevator Experts, LLC. Now, 8 years later, his organization is one of the largest independently owned and operated vertical transportation professional services firms. Thank you, Chris. Appreciate you joining us, and I will turn it over to you.
Perfect. Thank you very much, John. If everyone noticed that John and I, he is my older brother. He and our uncle brought me into this elevator business 20 years ago, and it's been a wild ride ever since. So again, as John said, so I started Liberty 8 years ago now. It's been tremendous, and throughout the success of that has always been looking forward to seeing what those disruptors in the market are, what's going on there. As Guneet mentioned, disruptors, and those are always powerful things. They create an opportunity for those that are willing to take advantage of that opportunity. Yeah, there's so many that happen through our lives, in our personal lives, with assumably most of the people that are taking part here with smartphones, with autonomous driving, with our internet service or television subscriptions. Before any of these happened, everyone would have thought that they were non-starters. The old way was the way that everything had to continue moving forward. Once those disruptors happen and the early adopters come on board and take a look at it and realize that this is something that's really viable, it continues to gain momentum and grow forward. And that's really what the IoT that Guneet was talking about, and that's also what alternative testing is. As I'm kind of explaining it here, I'm going to be referencing the alternative testing created by Henning and distributed in North America by Wertec. There's others out there. It's just the product that I'm the most familiar with, and it's the product that I have a set of, just to kind of show you a little bit of a demonstration of how you utilize the technology. So with everything with technology, you have to have buy-in, right? Everyone can fight the advancement of technology in any industry, certainly within the elevator industry. We have been very reluctant as an industry to adopt new technology for a long time. It hasn't been until recently, in the last 10 years, that our industry has started to pivot and make rapid changes and advancements into that technology space. The alternative testing is a continuation of that. It wasn't very long ago that everyone within the elevator industry would say that an overspeed governor has to be tested the same way. Several people standing shoulder to shoulder trying to squeeze in our tooling and our equipment and our testing instruments, until such time when it wasn't. Now we have governors that ride along top of elevators, and there's no way to verify what the trip speed are, what the set speeds are. We have to believe the technology that's giving us accurate information. That's continuing, throughout as IoT comes along and makes their advancements. More and more traditional features that someone had to go look at to verify is now being provided to us through some sort of technology and some sort of sensor. With the alternative testing especially, we have to take advancements in that space, because elevators, traction elevators, are being built and designed differently as well. I think most people would agree that the limitations of overspeed safeties are now being designed differently. It's not a question of good or bad, it's just different. Overspeed safeties have replacement criteria, they have limitations on it that are more restrictive, or the parameters within them are closer to the device that they're installed. Back in the heyday, one or two type of safeties went on all types of elevators, regardless of the speed or the capacity of the device. It was more of a one size fits all or a two size fits all. Now safeties are designed to complement the components that they're installed upon. And with all technology, to have a beneficial conversation, we can't play the what if game. you can play the what if game about everything. But certainly a dishonest person will find a way to be dishonest no matter what you do. If someone wanted to cheat the test, they're going to find a way. That person could find a way to cheat the test with traditional weights as well. Alternative testing has been in the code since 2013. It's been around. Of course, it's in all future codes beyond that. Not really going to talk much about code here, but obviously everything has to be adopted by your local AHJ. So wherever you are doing business, you need to communicate with your local AHJ and determine whether it's been adopted in that authority having jurisdiction. A little bit of history about the alternative testing. It's not new. It's been around for 20 years in Germany. They've been doing it successfully for 20 years. It's not even new into North America, really. It was first tested out in Michigan, University of Michigan, on a test site. It was a kind of an R&D project, or a research to understand exactly what this thing was, what it looked like, what it felt like. TSSA engineering came down out of Ontario just to further evaluate it. There were a number of representatives throughout the US from AHJs, manufacturers alike, all kind of came together just to see what this was, as this was new technology in 2008 being introduced to the market. It's continued to move forward. I wouldn't say it is widely accepted at this point, but it is continuing to gain momentum. More and more contractors are getting on board with it, and more AHJs are allowing it to be used. So it is in the 2013 and later. So if a jurisdiction is operating off of that code or a later edition, it is allowed, assuming the AHJ has not made any provisions to not allow it. So with alternative testing, it's all based around physics, and I'm certainly not a physicist by any means, but physics don't lie. They're a constant in the universe, right? So the basic understanding of why you don't need to put weights in an elevator. As the example here shows you a truck, just to give you an outside reference, the braking force of that will remain the same regardless of the load that's within it. Of course, the same is true for an elevator. When an elevator safeties are applied, the force that the safeties are applying to that elevator are going to remain the same, regardless of what the gross load of that elevator was at the time that the safeties are applied. What will change is the length of time that it took for the safeties to bring the load to an even stop. The way this device from Henning, the way it works, essentially, this is for a millimeter rope. They make them for all sizes, all types of ropes, but you apply these to the hoist ropes, and whether it's a belt or a metric system or an imperial system, use the proper sensor, tie it to the ropes. Sensor comes down to a small interface computer that remains on the car top with a seismometer. That device calculates and records the G-forces, the vibrations, the inertia, everything that is built into the algorithm that determines whether the safeties were capable of handling with that load. So when the safeties are set with with no capacity weight put in them, operating with an empty car, recording the forces that are imposed upon the safeties are then extrapolated to whatever the gross load would have been. With that, so when you take a moment to kind of think about that, it is very logical. The brakes don't apply, the safeties don't apply extra hard when there's more weight in the elevator. They're going to apply independent of the weight, because obviously they don't know how much weight is in the elevator. They don't know whether it's an empty capacity or not. They're going to apply, the elevator is going to stop. We hope. It can then just be extrapolated out to the rated load. It can also extrapolate beyond the rated load to tell you at what point it would not stop, which is information that has never been available to us in the past. With the change of design characteristics, especially with the MRL market, we all know when we try to do a safety test with weight carts, it can be challenging to fit the weight into the elevator in alignment where you can evenly distribute the weight so that you don't rack the car. We don't, again, it's one of these changes. In the old, we always really knew where the cables or the suspension means were attached, whether they were going to be underslung or 2-to-1 attached to the car. It didn't really change that much with older equipment. With the MRLs and with a lot of the modern designs, we really don't know what's going on until we look at it for ourselves. We don't know how far back the suspension means will be. We don't know if it's an underslung or an overslung. We don't know the rope configuration. Trying to center the weight around that suspension means so you don't rack it is very challenging in some cases. And of course, we've all seen cars get racked because of it, which becomes then a very destructive process, or you're trying to prevent any destruction, but you may find a whole gambit of problems with the safeties or the styles jammed into the rails and busted roller guides and everything alike. So there's four pieces really of this. It's the physical measurement of the mounting braking force of the safeties. When we set the safeties, we understand what that is. We don't need extra weight to determine that with the alternative testing. It will also determine whether we're misaligned or not, whether we have any racking in the car. It's going to verify that the measured amount of safety force is able to decelerate with 100% of the loaded car governor tripping speed, which is what we need per code, rated speed, rated load. It will then also determine, so when we do that, we don't have to measure the slide, right? Well, I should say the reason the code provides a slide is because there's no way that we can determine this in the field before this technology came around. The slide is appropriate to the rated speed of the elevator because we don't want the safety to set so aggressively that we're going to cause physical harm to a passenger that is in it. Certainly, manufacturing facilities and engineers could make an elevator stop on a dime if they wanted to. If you were in the elevator when that happened, you would end up, severely injured by that. So the characteristics of the slide that we all measure is allowing us, we want to be within that minimum and the maximum. That's telling us that we're not stopping too fast where we're going to cause injury to any riding passenger, but then we're also not going to slide indefinitely all the way down to the buffer. And then we verify the force of that deceleration. Again, right now it's a go-no-go. Did we stop within that realm? More on the engineering and the code stance of it, we know that window of slide is so that we can be within the acceptable G-forces of the deceleration. We can actually provide that now. It's just speaking as a consultant, there's an added benefit that is not the intention of it, but certainly having quantifiable data regarding the G-forces of the device stopping can help. Well, I guess it could help or hurt in a liability situation where there was an incident and you need to determine what happened. If your equipment's good, it's going to help you tremendously, which is where it always should be. It should never be bad. But that provides quantifiable data that was never available before. We never knew what the G-forces of a device were. We now can understand actually what are the G-forces imposed, making sure they're within code. And then, of course, again, it's a side benefit of the product, but if you ever needed to pull those records, you would have those records where it's real quantifiable data saying what the forces were with that elevator when it came to a stop. Taking the physical measurements of the brake, right? Again, right now, we have a go, no go. Elevator rated 125%, lowers to the next level, levels at the floor, doors open, doors close. So the drive controls it, the brake holds it. We can determine what the braking force is, the braking strength is now. It's the coefficient of friction of the brakes. We've never had that before, right? So it either works or it doesn't work. If it doesn't work, we got to take the brakes off and send them to a shop, or we got to replace the brakes and do something. We can't determine how close was it to working, or how close was it to failing, which is a more appropriate question. If it works, how close to that 125 will the device not hold? And then that empowers the elevator contractor or the owner to make their own decisions about risk mitigation. How close are they willing to have it work up until it wouldn't hold? We can get that real information now, that quantifiable data, to be able to better protect ourselves, better protect our clients, and better protect the riding public. When we set the safeties, when we apply the brakes, again, that information doesn't lie. The other piece of the testing is we want to run the elevator up. We want to see what the brakes force applies. Right now, we have no way of, prior to alternative testing, we have no way of determining whether we would stop in a loss of suspension means. I hear people say all the time that elevators have never actually, the only times that elevators have lost suspension are 2 or 3 times, and they name the World Trade Center the first time, and I think the Sears Tower. And there are many cases. Of course, it's still a very low percentage based upon the number of devices and the trips within the industry. Not saying that we have a major issue going on, but elevators do lose suspension means. It does happen, and it happens more often than you're aware. Of course, no one ever wants to talk about it, which is why people believe the only time it happened is when there was an outside influence caused the device to lose suspension means. But it has happened, and it's happened a good amount of times. And when you get a big enough group of expert witnesses in a room at an event, and they all start talking about different events that they've been called on, it obviously brings it to light that it does happen more often than we as an industry admit or want to know about, because no one wants to talk about it. So we can determine at what point the car will not. There was also a myth that the counterweight bounced when you applied the safeties, so it never really affected the loss of suspension would remain the same because the safeties set and the car bounced, the counterweight bounced during that time, and the safety still set, so therefore there is no counterbalance effect. We know by the data there absolutely is. The counterweight doesn't bounce enough to counteract. We can see that on the graph. We can see when the counterweight bounces and when it doesn't bounce, and it doesn't affect that loss of suspension ability. Again, this is all backed in science. I'm certainly not, like I said, I'm not a physicist. I can point you in the direction of Henning, and if you are capable of having that much higher level conversation, I can point you in the direction of them, and you can discuss it with them. Henning, they're an engineering firm. They have a wide variety of products regarding measurements and instruments, and I believe they have products outside of the vertical transportation industry, all within those measurements and instruments. So the only item that there may be someone saying, well, what about the buffer test regarding an oil buffer? The code says that we are supposed to strike the buffer at the rated speed with rated capacity within it, and how do we get around that? The safeties and the brake, okay, how do we get around that? Again, coming back to the engineering of an oil buffer, the pressure within an oil buffer when it is struck, the pressure is actually greater with a reduced capacity in it than when you're striking it with a heavier capacity, because the buffer, the rated speed is remaining the same. So you're asking that buffer to compress in the same speed of time. The elevator is not traveling when you're doing the test. The elevator is not traveling at a faster speed with the extra load in it. It's still traveling at that same speed. So you're still asking that buffer to compress within the same duration of time. The extra load is not affecting the compression of the buffer. Of course, the second part of it is the buffer returning, which again is not going to be determined on the load that the elevator hit the buffer when it struck the buffer. The rated speed is the crucial impact of there. And again, it's just an advancement of technology and an advancement of the way we think. It was just kind of felt good, you know, and this, of course, that code goes long before I was in the elevator business. That code has been a requirement, but it's a continuation of adjusting the way we think about things. So just a couple of things that I do always hear to wrap up, you know, there's always a comments about this seems like it's reducing man hours on what it takes to do a job. It doesn't reduce the man hours. It's still a two-person job. It still takes the same amount of time. You're just not pushing weight carts around. Certainly it does take someone that needs to be educated in the technology. So certainly the elevator contractors will need to invest in their technicians to train them how to use the equipment. They're not going to just be able to pick it up morning of and go to a job site. They're going to need to be trained on the equipment, learn how to use it. It is pretty user friendly, but training will be required nonetheless. You know, you're not going to have to push weight carts around. You're not going to have to drive weight carts to jobs. These are advancements. You know, potentially workman's comp from pushing weight carts is going to go away as well. You know, there's always a give and take. There's always a pro and con with things, but it's going in the direction of working smarter, not harder, utilizing the technology. And one of the, you know, talking about holding a contract that's sticky, having this information, if you're the one that has the equipment, you know, that's an advantage. That's a competitive advantage for you with the service contractor, with your client, the property owner or management firm, because you have all this data now. You have this quantifiable data. It becomes part of the maintenance control program, the on-site documentation, of course, but you're the one that can duplicate that data in 5 years again when the test is required. And it can also give, used properly, I think it can give, you know, key insight to the alteration in the sales department when a company determines at what point do they feel close enough is too close. When they're getting too close to safety's not setting or brakes not working, at what point does that trigger a company's sales and alteration process to begin? So with that, you know, I'll turn it back over to John, but these are some of the highlights. And like I said, I've been a believer in it now for a number of years. I've went to Canada to use it up with TSSA. I've seen it on a number of locations, and we have a set of it ourselves at Liberty, and I'm a believer in it.
Thanks, Chris. Just, I guess, a couple of, you know, comments and maybe a question or two built in here. You know, the first comment or the first takeaway was, you know, from the presentation was, you know, absolutely we have to get, you know, better about, you know, trusting these things, right? Because the old days of, you know, being able to always physically verify are not always possible with new technology, right? We used to be able to, I don't know, see a pressure gauge on a valve, and now sometimes the valve is in the pit in an unsafe place, and we need to rely on a screen on a controller. And this is probably very similar. So, you know, we've run into each other at code committees. I mean, I know you sit on some various committees and you're actively involved with ASME. So how does ASME, or how does the code ensure that the alternative testing result can be trusted, so that the end user in the field, you know, has that confidence that they need to have in order to verify and trust in the device?
Sure. Yeah. So that's a great question. So the way the code addresses it is you have to create a baseline. So the first time that alternative testing is used, whether it's on commissioning of a device or any subsequent Cat5 tests for the life of that device, the first time it's utilized, you have to create that baseline. So you're going to perform your safety test with your capacity on site, and you'll perform your brake test with your 125% on site, and simultaneously or after the fact, you'll perform the test with alternative testing. Now that has created your baseline technology, because our baseline information, because we've seen it work with weights, so we know that it works. Now we create that alternative testing information, providing our G-forces, providing our stopping forces, at what point we will not stop, at what point what would happen if we lose our counterbalance. Then from then on, that initial alternative testing result is the measure that we compare it to. So moving forward indefinitely, whether the device is, you know, operating for 25, 30 years, every future test the alternative testing, you compare those results to the original results, which of course is, you know, going to be saved in your laptop. You have to have the on-site documentation for the record, but you'll be able to just pull it up and compare right there, you know, on your device.
So to follow up then, what happens if you go through that process and you do the full load test with the weight, and then you do the alternative test, and what if I have different results? Then what does the code require that I do?
So that, you know, it's not a good thing in the sense that you don't want to have the different results, but it's a good sense. So it never changes until the device has changed. So when you've created that baseline and now you're years down the line and you're doing future testing and you see something's changed, the reason it's changed is because that device has changed. Either the safeties have went beyond their usable life cycle and they're in the replacement criteria. Because again, so there are safeties out there that are good for 5 uses, good for 7 uses. I think most people would agree they may not necessarily be recorded. The safety sets may not be recorded appropriately. An adjuster may have set it 1 or 2 extra times to get things ready. We set it, if you're doing a pre-inspection, you may have set it, and you did the commissioning, you may have set it. We may be approaching replacement, you know, criteria before that device ever gets into operation. The moment that result changes, it's changed because something has changed on that device. Without that, we can't determine it. We can't determine that we have a problem because we're only working in that world of go, no go. So now we can see something has changed. Someone, and again, coming back with the MRLs, someone could have changed the flooring in the elevator and the service contractor could not be aware of it. Changing it from carpet to a tile, that weight significantly changed. Something has changed. So what it's doing is it's shined a spotlight on it now, because, and certainly the same mechanic may not be there throughout that 5-year duration. So the mechanic may not, no one can be completely oblivious to what has changed. Cab alteration, failing equipment, brake deterioration. This is shining a spotlight on it now, saying something has changed. And it's not that the equipment changed, it's that something with this device gross load has changed. There's a deterioration of a component, or we're beyond the usable life of that safety. So it's really triggering, it's shining a spotlight on either a major repair or an alteration of some kind. Counterweight balance may need to be adjusted if they change the weight of the cab. And certainly the elevator contractor, even though you may have held it under contract for that entire 5-year duration plus, you may not be aware of what changed. So this is shining a spotlight. The moment you see a different result, something has changed on that device, and now you need to go investigate through the on-site documentation, through speaking with the client, whatever, to figure out what has happened. And now you need to go through that corrective action to figure out whatever changed obviously needs to be reversed, or it certainly needs to at least be compensated for in another means.
Okay, great. Thank you for that. I am going to now move over to next member of our panel, who is Sean Madden with Madden Elevator. Sean's the president, CEO, and owner of Madden Elevator Company in Louisville, Kentucky, which was founded 11 years ago. Sean has been a member of NAEC for 29 years and has had a steady industry progression over that time. Starting as a helper in the field with installation and repairs, he grew into roles such as mechanic, supervisor, and eventually business owner. Sean has his CETS, CATS, and QEI certifications and has served on numerous NAEC committees over the years, including the certification board. And Sean just started his 3-year term on the NAEC board of directors in New Orleans. So Sean, thanks for coming, and I will turn it over to you.
Thank you, John. Appreciate it. I'm going to share my screen here. So today we're going to talk a little bit about how elevator contractors and suppliers can use IoT and technology. What a fun topic, right? There's a lot of changes in our industry and outside of our industry. Guneet did a really good job of talking about some ways they're looking at that technology differently. And I really appreciated Chris's take on how alternate testing and technology is going to be used. So what I want to talk about today is not just elevator monitoring, but a variety of different ways that you can use technology in our industry. As John mentioned, started out in the field, started working service in Daytona Beach out of a Jeep CJ5. That's just a little fun tidbit. Started, my dad came from the Air Force and he ended up going and putting elevators in New York City. And actually, I didn't even know until after he was passed that he was part of the installation in the elevators of the World Trade Center. So that's pretty cool little tidbit that many people don't know, and I didn't even know until after he was passed. But as John mentioned, I feel like I have a really good progression in the industry. I spent about a third of my career in the field, another third in management, and then the last third in executive management and ownership. So it's been a great progression, and just a little more tidbit background on me. So today we're going to talk about IoT, and just want to give you a little basis. I'm not going to go into grave detail about this stuff, but this PowerPoint will be available for future reading if you all want. So it's really just connecting devices to the internet and trying to figure out what are these devices doing and what are they saying and how do they work. So, how does IoT work in general terms? You're basically integrating data from a variety of different sensors. And you're looking at that analytics, and you're taking that analytics and applying it to those different devices. It doesn't specifically have to be elevator monitors. It could be a variety of different things. So some features in IoT, some real important things to think about is connectivity. Obviously, that's one of the big pieces. How are you going to connect it? Are you going to have to connect it to Wi-Fi? Or you're going to have to get into the building connection systems? And today with some of the phone technology, it's became a lot more easy. So that's made some of the IoT stuff in our industry a little bit easier to connect. Analyzing is a big piece. Integrating into your systems or not integrating. active engagement, and there's a ton of other stuff. We won't get into all of them, but we're going to pick some top level things to kind of talk about. So what's the real function of IoT? Well, it's really just pinpointing what's the useful information. What can we use and try to figure out that's relevant and important? And what can we not use and make sure that we're not affecting safety? So there's a lot of direct patterns and recommendations that can come out of that. And you can really, on some of the things, you can detect problems before they even occur. And all that comes with time. Obviously, there's a lot of concerns with IoT. So I picked 5 major concerns. One of them is obviously connectivity. How are you going to connect the information? Integrating different hardware devices. So just, there's not one device, there could be 20 devices. How are you going to integrate all that and get it all talking together and get it helping each other? And then the interoperability between different platforms, because everyone might have a device, but how is it going to talk to another platform? So figuring that stuff out. And then of course, security. Anytime you're connected to the internet, we're all concerned about the security if somebody can get in there and hack it, because people ride on what we do. And then obviously cost, big factor, and it's came down a lot over the years and came down a lot lately, which has allowed some of this technology to come into our industry. But really the biggest thing is 90% of the people who are trying to figure out how to connect, how to find the right connectivity to these type of devices. So as you all know, IoT is all around us. It's in our smartphones that we all carry. I doubt anybody has the old flip phones or pagers anymore. But it's everywhere we look. I mean, there's smart appliances, stoves, refrigerators, washers, dryers, coffee pots, that kind of stuff. I'm sure you all have seen like smart security systems, locks and ring doorbells and that kind of stuff. And then of course there's the home hubs, which is the leader of IoT technology, controlling lighting, controlling heating and cooling. You can do just about anything you want to do in your house from anywhere in the world, which is pretty amazing. But smartphones, Apple Watches, Amazon Alexa, there's a lot more. Many devices are in this world of IoT and technology. So I want to talk about an interesting little example. So if you're really connected in this IoT world and how it's learning things, let's just say, for example, you get up at the same time every day, your alarm goes off, you get up, you ride the train to work, you get to work. Well, if you're not connected and there's anything that hiccups your day, you're going to be late for work, right? Well, what if there's a day what if there's a system that says, hey, I know the train's out, I need to move the alarm clock up a little bit. And oh, I'm checking the weather, and by the way, it's raining, so you're going to have to drive, but you're going to drive slower. So I'm going to make that change. And oh, by the way, you got a coffee pot that's connected to the system, so they're going to make sure your coffee's ready when you get up. This is all happening today, people. So it's really neat if you think about a story like that, and you're really connected and integrated in all those pieces, and all that moved back, and you can actually get up on time. You can get to your car, you can drive slow, you don't have to worry about being late for work, and you can have coffee because it connected and was there earlier. So these are just some little examples of fun examples of things that's like, wow, I never really realized that was out there. Another interesting example is, you all know cars are connected, and there are ways to connect cars with various manufacturers. Like your car, if you're driving to work, you could actually, if your car had a problem and the light came on, it could connect to the manufacturer. It's going to look at that problem. It's going to compare it to all the other cars and say, what exactly is going on? And, oh, well, this is a minor issue. I think we can schedule an appointment. We can make sure they got the parts available. And then we can send an alert to you and tell you, hey, you got an appointment on Tuesday to take your car in to get that check engine light fixed. Well, conversely, maybe it's a major issue and they need to tell you where the closest place to go and get it worked on because you need to get something done right away. That's what technology can do for us. So those are just a couple of little quick examples. There's a lot of popular IoT, and as you can tell with this chart, smart home is by far the biggest and fastest growing. The second one, which was a little surprising is wearables, like the wearable devices like the Apple Watch and that kind of stuff. That's really taken off, and people are really, trying to use that stuff to understand their health better, to understand what they're doing on a day-to-day basis better. There's a lot of other things like smart cities and smart grids, but industrial internet is kind of the world we live in, and it's grown a lot in the 5 years in the last 5 years, and that's really grown a lot in the last few years, but it's already up to 25%, even above cars. So I found that pretty interesting. So how big is smart elevator market? Well, it's a pretty big market. There's a stat that said $18.75 billion in 2019. And it's expected to be $38.27 billion by 2027, which is only 6 years away now. So it's growing fast. And, as most of us are familiar with, a lot of the major companies are investing a lot in this to make elevators smarter. So here's the real big question. What does it do for us? How does it relate to our industry? What can we talk about that makes sense that we could take home and use? So I'm going to talk a little bit about AI, artificial intelligence, machine learning, and talk a little bit about automating business systems and processes, and then just embracing and utilizing these advances in this technology to figure out how might you be able to use it in your business, whether you're an elevator company, a consultant, or even a supplier. Everyone's trying to figure out how to use technology to make your life better, and we're going to go through a few of them things. So here are 5 IoT trends in the elevator market. So interesting stat, there's over 12 million elevators worldwide. We move more than 1 billion people a day, which is the most used transportation in the world. So you may not even think about that, but our industry moves more people than anything else in the world. That's a huge factor when you step back and think about that, because we're a very small niche industry, and we move more people than anybody. So it kind of makes you think, wow, we need to be embracing technology and utilizing some of these things in better ways. So here's 5 IoT elevator trends, which is connectivity. We talked a little bit about that. The word everybody loves, predictive maintenance. Everybody loves that word. We'll talk a little bit about that. Smart touchless panels. They seem to be, obviously with COVID upcoming, the touchless panels and the technology with the COPs. Cable-free elevators, that's an interesting one. And then dispatching technology. There's a lot of other ones. Just pick 5 top ones that seem to be relevant to our industry. So connectivity, this is where the market's really growing and a lot of things are coming online. Is every elevator in the majors are being connected, and in many elevator outside of the majors. So connecting elevators to the internet means a lot. It's like, how do we utilize the information we're getting? Some companies are connecting them to building maintenance systems, building management systems, like utilizing other things in the building, and also have the elevator system right there in front of them. We've even installed years ago where you can actually run an elevator with, you're all familiar with LiftNet's product, but it's similar to that, where you can see what's going on with your elevator, where a customer could see it right there at the dashboard. And a lot of it is about proactively understanding what's going on, seeing faults when they happen or before they happen. And quite frankly, a lot of people are managing their buildings and aren't in the building anymore. So that's really going to drive a lot of this too. And the reason for it is just really to proactively figure out how you can save time and money. I mean, when it really comes down to it, that's what it's about. So the fun one, predictive maintenance. So this is about collecting data, sending it to the cloud, and letting algorithms compare these data with a variety of different types of elevators, or a variety of elevators in your particular portfolio. So you compare how much, based on a type of building, what's going on with that, and a type of equipment. And all this is kind of done behind the scenes in a matter of seconds. But if something's off, it flags and says, hey, something ain't right. And then engineers can look at that information and say, well, Yeah, I see what you're saying, and I believe that to be true based on my other stats. Let's go ahead and make sure that we have parts available. Let's go ahead and plan this out before something actually happens. So you can rectify a lot of situations before they actually happen. Now, it's not going to be an end all. I don't think it'll ever be an end all, but it does give you information to help you understand the status. So as you continually monitor these things, you're really understanding the status of the components, how fast the car is accelerating, how fast it's stopping, are the doors opening and closing in normal cycles? Is there something else going on with it? And then, that's just to name a few of the things that these algorithms can do. Interactive touch panels. I'm not going to spend a lot of time on this. This is about providing passengers entertainment in the car. It's in a lot of the big buildings. You all are familiar with it. It can also change like the mood of the elevator and certain, if there's something going on in the building and they want to have, special trees on it. But also using the information on those interactive touch panels or even touchless panels, you can understand like what a rider's doing and change the functions of what's going on with the elevator based on how it's actually being utilized. And then of course, the big one is always detecting emergencies and automating calls if it's possible to automate quicker. So this is all increasing the public, riding public's comfort and what they like. And then no cables, that's an interesting one. It's coming, we're gonna have to get prepared for it. We're familiar with elevators that go up and down. There's elevators that go forward and backwards, left and right. They're riding on magnetic rails. So, those types of elevators are gonna be, they're gonna be here. And well, they are here. They're gonna be in our market soon. And it's really about energy efficiency and improving carbon footprint. And then dispatching, buzzword is, destination-based models. Understanding building flows and grouping people in areas to go to certain elevators that can go to that group of floors. And it really results in better and faster organized passenger movement. If you remember the old days, there was a lot of people standing in the lobby waiting on an elevator and whoever got there first. So these technologies have really improved where that flow can work better. There was actually proof that there's a 40% reduction in overall traveling time, as well as a 27% energy consumption savings. So those are pretty big numbers. Some ways to use IoT in ERP systems, and I'm just gonna touch on a few of these. It's about trying to figure out how do we improve our business systems. You can do it by linking processes on how you work in your departments. You can do it by reducing repetitive tasks, whether it's ARAP, writing checks. You can connect AI learning devices. And then obviously the elevator machine learning side of the industry is growing a lot, and you can automate workflows with a lot of that stuff. So we're going to talk a little bit about that. Linking processes between departments. Really, this is just pretty straightforward. You're linking finance, you're linking human resource, sales management, inventory, and you're automating those interactions. So you have a process, for example, say you have a sales order. Well, if you put that order in, then you get it approved, you can have the system automatically interact with all the other departments, whether it be inventory, finance, shipping, and you really just save a lot of time and money and energy and effort, fewer routine errors, unintended duplicate of data, streamless communication. I know you all have dealt with this kind of stuff in whatever business you're in. And then it's really about just performing data analytics on how you're working. And then in smart ERP systems that you can really make informed business decisions on what's going on in your business instead of spending time just doing that kind of stuff. We're going to talk a little bit about repetitive tasks. This is a big one for me. It's all about using the AI and understanding what are the same tasks you're doing over and over again, and how can you improve that so you don't have to do that. Like improve automated workflows, advanced record keeping, future forecast abilities, and actionable reports automatically in your inbox. Those are the big pieces of what new automated ERP systems can give you. But here's the big one. I think you can really reduce repetitive routine tasks And you can have people, instead of spending time on that kind of stuff, you can have them spending time on things that really matter to your business. You know, they can do a lot more analytical type work or creative type work, and then they're really contributing to your organizational goals. So instead of you just paying somebody to do the same thing over and over again, they're actually thinking for you and helping you drive your business forward. And then the ERP censored IoT, Guneet talked a little bit about this. There's several products on the market. It's all about understanding where is it coming from. Well, there's a lot of sensor-based technology out there, and there's a lot of things that's changed, like broadband internet and sensor technology has come a really long way in the last few years. So how does this help manufacturers and suppliers? Well, reduce maintenance, increase uptime, longer product life cycles. How does it help benefit the end user? Will obviously reduce product failure, reduce operating expenses, and then ultimately your equipment can last longer. So I'm going to just go through a couple of final key points. So elevator performance data is all about understanding the data and how it helps you. So some ways you can do that is focus your maintenance, you know, understand what it's telling you and have a focused area for your maintenance control program that may actually change on a month-to-month basis based on how that elevator or that building is being utilized. Now you're using data to maintain your elevator per what the code actually tells you you're supposed to do. Some benefits are it actually helps reduce downtime, and it's going to help reduce your maintenance expense. So you're not spending a lot of needless time going to do something that isn't necessary or may not be necessary every single visit. And here's some just general reports that can be used to understand what's going on with the elevator usage and performance. You can compare customer uptime. You can look at unit comparisons, like if it's in a certain building that's a two-story office building and you compare it to another two-story office building, and you understand one runs 3 times more than the other, well, obviously that's going to need more maintenance. You can also understand, jerk rates and speed variations and horizontal vibrations, just a few of the different kind of reports that are out there. And then one of the things that is really hard is get your techs on board with this. Get them to understand, how can I use this information to do my job better? Not necessarily take work away from them, but do their job better. By understanding ride quality anomalies, understanding what floors does the elevator service the most. And let me spend a little more time on that one than one that it hardly went to last month, if you are going monthly. And then also, just understanding the basics of what's going on, like if there's a power outage, they can understand those power clips and that kind of stuff. So there's a lot of things you can do, but listen, AI and elevator monitoring and remote monitoring or IoT or whatever you want to call it, it's never going to replace the technician and the ability for them to go look, listen, and feel. That's what they're good at, but it does allow them to use the data to help them focus their efforts and their time. And they are one of our most expensive assets in our business. And then here's just a couple more little behind the scenes data shots. You can see like where the car is spending time. You can do traffic analysis. And then, this is the last screen. I'm just going to show you a few more things. There's a lot you can do with this. With heat maps, you can see where the car is spending time in 15-minute intervals. You can see where the car is going during different hours of the day. And all this information is very helpful and useful as you talk to the building owners and say, hey, listen, I'm understanding what's going on with your elevator. Here's some things we need to look at. Maybe we need to not service during these times. Maybe we need to service more during these months. And this data is extremely beneficial to help maintain their elevator differently. So in just summary up, 3 key things here. Just consider ways of how you can embrace technology. Know that it's not going to happen overnight, and determine what small steps you can make with AI to help your business. So John, with that, I'm going to turn it back over to you.
Thanks, Sean. We've got about 9 minutes here, so I'll try to make this quick. I do have one question, but before I get to the question, just a thing that stood out to me that I really liked about what I heard from your presentation there. What I heard was that you're using IoT not to replace the mechanic, not to defer the maintenance, but to do the maintenance, in a more logical or in a more informed manner, which, I think is possibly the key difference to what your approach is, and maybe others, compared to, what we at least as independents maybe have thought about, the traditional remote monitoring approach. So that was, extremely interesting to me, and I hope that's fair,
Yep.
kind of. My question though is there's a lot of technology available. You're kind of seem to be in Madden Elevators kind of on the forefront of adopting a lot of that technology. So if I'm a contractor who is looking to start to implement some of these things that you went through, how would you suggest that they can start to kind of implement some of those technologies, maybe in small pieces or in a logical kind of manner that makes sense without being overwhelming?
Yeah, really good question. Technology can be overwhelming even in our personal lives. There's so much out there and we get hit in so many ways. And quite frankly, that was one of the reasons some of the failures of the early elevator monitoring, because, you would get hit with so much information that it wasn't actionable. So the goal is to understand, what can I get that's actionable information that can help me run my business better, drive, and do better service on elevators. To get back to your question, it's really just trying to maybe pick a couple things and focus on testing it. Try one of something and just play with it a little bit instead of just trying to do everything overnight. And that's what a lot of times happens, and it's happened with me, where you start, oh, I want to do this. Oh, it'd be cool if I could do this. Well, what if I could do this? And the next thing you know, the project has become so big, you're like, I can't even get my arms around it. So I would suggest picking one thing that you think is important to you and go out and test just that one thing a little bit and get a feel for it and what it might be able to do for you. And you'll learn a lot through the process. And then you might be able to go to the next step. So just small bite-sized pieces. What do they say? Eat an elephant one bite at a time, right?
Exactly. Thank you for that. It looks like we've got about, 5-6 minutes left. I do see that one question came in. It looks like, Guneet answered that question. There is one unanswered question at the moment, not instructed to any one panelist. So I guess it's kind of open to everyone. And the question is, and I'm going to paraphrase here, why is it in the US that the IoT tools are not constructed or coming from the controller manufacturers? I'm not sure who may or may not want to jump in on that one.
You got that, Guneet?
Yeah, I was thinking of giving an answer. I don't know if you guys can see me, but I actually don't know. I'm not familiar with the elevator controllers that much. I don't know if Sean or Chris, y'all know, but I don't know. It's a really good question.
Well, I think the answer is on the major side, they just, that's their technology that they are keeping for their own competitive advantage. On the independent controller manufacturers, I think companies are starting to look that way, but obviously there's a big R&D investment. So that I think they want to make sure that the market is actually going to utilize it if they're going to invest that kind of money into it. But the majors have been doing this now for 15 years or so.
Yeah, and just to add a little bit to that, we've had some success over the years with a variety of different companies connecting controller manufacturers to a variety of elevator monitoring systems. And I think we'll get there as an industry. It's just our industry is always very slow to adapting technology. A lot's changing in the last few years, and I think the pandemic actually helped that. So I foresee a lot more US controller companies figuring out either how to make their systems work better in terms of that stuff, and or connecting with other elevator type monitoring systems, because it's ultimately to find a way to do better service and give more reliable elevators and safer elevators as well.
Thanks, guys. There's another question that just came in, directed at me. I'm not sure if I should answer this one or not, but I'll certainly give it my honest opinion, and then I'll let any of the panelists jump in on this. The question is, you know, John, why do you think remote monitoring hasn't worked previously? You know, in my opinion, I think it's maybe potentially a number of reasons. First and foremost, I think it's a little bit of what Sean touched on in his presentation, which is, you know, early on we've known we've had the ability to put sensors on elevators and start capturing all this data, but it was kind of just noise. It's, you know, what did we do with all that data? How do we turn that into, you know, meaningful and actionable items? And then I think we started to learn how to do that. And then there's the cost component. You know, it was expensive, you know, when it first came out. So I think there's an economic reason potentially behind that. But and I also think, you know, a large part of our industry, at least in the US, is made up of independents. And when we think about the ways in which this was first introduced to the market, I don't know if it's fair, but I think a lot of people looked at it as not as a mechanism to complement maintenance, or not as a mechanism to improve maintenance, but a mechanism to maybe not show up. And that there was some conflict there. That's my answer. I don't know if anybody else wants to jump in on that one. We got a minute or two left.
I think you did a very, very good job outlining the variety of reasons. I think another one I'd add to it is the technology today. Like, you know, components are cheaper. We can get the information out to the internet less expensive. So I think a lot of the technology advances has allowed us to be able to actually do some remote monitoring and some algorithms behind the scenes that we don't even know where this is going to go yet, but we're just testing to try to figure out how to make it work the best for us.
Yeah, the only thing that I would add to that, John, is that we as a society are now ready to accept it. Because of all the things that are in our lives now, that we had trust our technology. We trust like Sean said, we trust our phone to turn our lights on, turn our heaters and air conditioners on. We do all this stuff now. It's not an alien thing to us anymore to have some piece of technology, you know, providing us greater information and making our lives easier.
All right, well, thank you, everyone. It's kind of 3:30 on the nose, and we try to wrap on time. So out of respect for everybody's time, you know, again, we've come to the end of this town hall event. Appreciate everyone that joined us today. Certainly appreciate the time that all the panelists put together for putting their presentations together and presenting here today. We will be holding more town hall events like this one in 2022. So look for those announcements coming soon with topics and schedules. And thanks again for everyone for coming, and enjoy the holiday season with your families. And we will see everyone after the new year. Thank you.
Thanks, everybody. Thanks, guys.
Take care.